Welcome to tutorial number 2 of HVAC sizing tool, or HVAC street. In this tutorial we'll be covering the basics of entering a building and calculating the heating and cooling load of the building. So with me today is Bruce Manclark of ClearResult.
Greetings.
And my name is Christopher Diamond. I work for the Northwest Energy Efficiency Alliance. This project has been funded by the utilities of the Pacific Northwest that fund NEA, as well as support from ClearResult. Today's tutorial will cover information on how to enter a building. You should be able to enter a simple building, adjust default values, and review and understand the results. It's intended for HVAC system designers, residential energy efficiency experts, and utility program staff. So just to be clear, this tutorial will not make you an HVAC expert. To get the most out of this training, you should be familiar with ACA Manual J and the basics of residential HVAC system design. The tool is based on ACA Manual J calculational method with some assumptions used to expedite small building system design. It is not an ACA certified tool. This report and any values, estimates, and recommendations herein are only intended to assist you in evaluating your options and should not be used in lieu of professional engineering services. Moreover, the results are as is, without any warranty or representation regarding quality, accuracy, infringement, or other usefulness. Okay, all that said, we have tested this in comparison to the ACA certified tools over hundreds of systems across the United States, and in all cases they resulted in the same system design choices. So now we're going to show you how to enter a project. When you first log into the program, you'll come to the sites list, which is going to contain all the projects you've entered, and it keeps these in the cloud so you don't have to worry about losing them. And you'll be able to choose one of your existing project sites or create a new one. In this case, we're going to have Bruce tell us a little bit about a demo tutorial project that he's developed.
It's a very simple house. It's 30 feet by 40 feet. It's giving us 1,200 square feet. It's got 2 bedrooms, a bathroom, a living room, and a kitchen area, and a very small hallway. It's got moderate amounts of insulation, so this should be a pretty fast house to enter.
Okay, now we're going to show you the basics of entering the house. Since this is a tutorial, we've already entered a partially completed version of this house. If this is your first time, you may have to enter it from a blank starting screen.
This is the Site tab, and as the name would imply, we enter a lot of site information in it. The project name gives you 1 or 2 addresses that you can put in for it. Obviously, picking the correct state is important. Zip codes are also important. If it's a new construction project, you can label the subdivision, the lot number. It might not have a street address. You can handle the model number, etc. Obviously, picking the right weather station is very critical. If you enter the wrong weather station, you will get the wrong results. In this case, we are going to pick Kennewick, Washington. Builder, again, new construction, it's a good thing to keep track of. And if you're working underneath a utility program or just want to keep track of who the electric provider is, you can click one of those too.
And I think it's valuable to point out at this point, this is only 4 states are enabled with only 4 states of data. In the future, we may actually include more states.
The building tab is when we start to fill out detailed information about the building. First cell that they want filled is the conditioned floor area. It's critical to get this as exact as you can, because when you do the room by room buildup, the room by room buildup has to equal the conditioned floor area or you'll get an error. Floors above grade, that's above grade, don't include basements there. Average wall height, if you have a room that's above the average wall height, that's okay, you can adjust that later. Number of bedrooms, that's used for a couple of calculations, including ventilation rates. This next little tab here, the default insulation level, is really critical to get this right. It's basically going to pre-populate a lot of the data fields for you. You can adjust later, but the more exact you get this, the less time you spend entering data. Foundation type, you can see you've got your choices there. Also, there's one called custom where you can say, hey, it's half a slab and half a crawl space. Duct location, this is important to calculate the duct multiplier. You got 3 choices. It's going to be in the attic, it's going to be in the crawl space, it's going to be a conditioned area, or in the case of ductless, you'll have no ducts. Orientation of the front door is important, mainly just for keeping track of everything. Year built is also critical. The year built goes into a couple of calculations, including the air exchange rate of the house. You can also notice down here, if you want to associate any files, maybe the blueprints, maybe architectural notes, this is a place where you can upload and attach the file for later reference. Now that we have the building information entered and saved, we've moved into rooms. You can see that we've already got 4 of the rooms already entered. So we're just going to enter 2 rooms. First of all, we're going to enter the living room. So we're going to go in there and say new room. You can choose from a list of rooms or create your own name if you want. We enter the floor area.
500 square feet.
Just 5.
And then the exterior wall length. What is the exterior wall length all about?
Yeah, thank you. This is only the exterior length that is exposed to the outdoor conditions or maybe a buffer space like the garage. You do not enter interior walls.
So this is actually a combination of a couple of different lengths here, right? It's equal to 25 feet plus 20 feet. And I can put an equation in here and then hit tab and it calculates it.
Yay. If this room has a different height than what you said the default wall height was earlier, you can enter it here. If not, you can leave it blank and it'll use the default one. We move on to unconditioned ceiling area. Basically what this says is what % of this room is exposed to an attic, an unconditioned space. It's a single-story house, so the answer is going to be 100%. Same with the floor area. 100% of this room is exposed to heat loss area, i.e. the crawl space.
Hey Bruce, I'm going to go back and make the living room height tall for some reason. I'm feeling like this house needs a tall living room. You okay with that?
I'm fine. And that could be the average height if it was a vaulted ceiling.
Right. Okay, the last room.
We're going to go ahead and enter the kitchen.
And that was 200 square feet, as I recall, with 30 feet of exterior, and same thing, right?
Yeah.
100% unconditioned ceiling, 100%. All right.
Yeah, Chris, if we could just go up to the right-hand side of the screen right now, up higher where it's right there, you can sort of see what I call the video game scorecard starts being made. You can see the heating and cooling load right now. What's nice is you can kind of do what-if analysis as you go through this. But it's sort of educational, just having that real-time feedback. And once again, hit our favorite button, save.
So when I hit save, it updated all these values up here. It suddenly changed them.
Yes, you have to hit save in order to calculate.
Okay.
Now that we have all the rooms entered, we're going to move to the Windows tab. As you can see here, we've already got the windows entered for the first 4 rooms, and you can enter them in just about any direction that you want. And the direction is really important for calculating the solar gain. So we're going to go ahead and enter the first windows for the living room.
What is that, 25?
Yeah, we've got 25 square feet facing north.
All right, see a little diagram down there?
And another 50 square feet facing west.
West, 50. Any skylights?
We've got 1 skylight in the living room, 6 square feet.
Okay. And the kitchen?
Kitchen, we have a 30 square foot window facing south.
And then I hit save.
You know, while we're here, why don't we give the house some doors, Chris?
Oh.
Why don't we say the living room's got a 20 square foot door?
Okay. That's good. Where else do we want to door?
And we'll give a door coming off the kitchen also.
All right, hit save.
Okay, now we have the basic information of the house entered. Some of you may have noticed when we were entering windows that after we got more windows entered, when we hit save, that the heating and cooling load both increased somewhat. Overrides and options are critical functions in the sizing tool. It allows you to customize the house and use the best available information. So let's go ahead and click on overrides. When you chose the default house as being, a 2x4 insulated house with moderate levels of insulation and vinyl windows built in 1980, this is how this got built out. Everything from ceiling U values, you can see that the default was R19. We said, hey, it's gone through utility weatherization program. We've increased it to R38. Other critical ones down here, especially around windows, we changed it from the default of 0.58 to 0.40. We could also go ahead and take a look at the solar heat gain coefficient if we wanted to. In the Northwest, you'll generally find that the U value and the solar heat gain coefficient march right along. If you happen to buy a Class 30 window, chances are the solar heat gain coefficient is going to be about 30 also. That can make a very big difference on the cooling load. Two really critical buttons here, if you will, happen to be the duct leakage. This is really, really critical. Please, when you're using this program, please read the pop-up help. Tight means very, very tight, and leaky means darn near disconnected. If you don't know any better, average is a really good place to start. If the duct has been sealed through a program, probably enter semi-tight. In new construction, either enter tight or semi-tight. ACH, or air change rates per hour, that's largely based on the age of the house. If you have better information based on a blower door number, please go ahead and enter it.
All right, so we're gonna hit save after I changed it from semi-tight from the default. Oh, it went down a little bit, not much.
Okay, now that we have the overrides taken care of, let's move on to options. Options gives you the chance to customize things a little more, such as the design conditions. When you entered the house and you said it was, located in Kennewick, Washington, it entered all this information about latitude and elevation, heating design and cooling design. You can override. Let's say we're going to override the 11 degrees winter design temperature for Kennewick. Why don't we go ahead and say, I know it's really cold there. We're going to say 0.
0.
Notice you don't get to do that. There's a range that you can enter. So you can't say move a house from Portland to Phoenix if you want to justify a 5-ton air conditioner. Let's see if it'll take 7.
Still cold.
Still cold. Notice you didn't get the air button, and it also tells you what the allowable range is. We do have microclimates. You can change it some, but you can't dramatically change it. Further down on the page, some other options here. The number of people, that's used primarily for calculating the ventilation load. Below that, you have the appliance and lighting load. Ventilation, the way this program works is that it will continuously have 35 CFM of ventilation, of added ventilation on top of any infiltration loads. So if it does not have a dedicated ventilation system, you should override it with a 0.
And so this is all based on ASHRAE 62.2 assumptions, right?
That's correct. It does the ASHRAE calculations for you.
And I noticed that this appliance lighting and load, that's some sort of generic average 2,400 BTU per hour base load. When should we worry about changing these things?
That's a really good question. If you have a lot of internal gain, say if you have somebody with an aquarium, or if you have somebody with a commercial kitchen in the house, you should consider it at that point. One thing I will point out is that appliances have gotten newer. The amount of waste heat that they contribute to the house has gotten smaller.
And this has a pretty big impact on cooling, as I recall.
Yeah, in this case it adds 2,400 BTUs to it.
So let's try adding 4,500 here. Hit save, and I'll see what happens to cooling. We're currently 19,000. Oh,
there you go. You increased it.
Excellent.
And this is your last chance to influence the heating duct multiplier and the cooling duct multiplier. Again, these are really big knobs. You can really change the size of the equipment by doing this. We certainly urge you never to size a piece of heating equipment on a lousy uninsulated duct system. We think the first move is to seal and insulate it rather than entering something, say, like 50%. Again, these are calculated based on the R value that you gave it, the degree of leakiness, and those are based on primarily the age of the house that you enter.
All right, so now that we've got the overrides and options done, we're going to skip forward to results and show you a little bit about that. These other tabs we're going to cover in a different tutorials. On the results tab, this is something you can print out, and it'll contain information about the project site, the heating system, anything you've entered in about that. But I'm going scrolling down here to kind of show you, make sure you've put in the window orientations in room areas correctly. The building data is all as you desired. And then ultimately you come down to these room data and loads. And in this location you can actually enter in changes in which you've observed after the building's been built. You could actually enter in what was the actually observed or measured building CFM if you actually tested that. But ultimately what we're really interested in is, hey, how did this building do? What was the ultimate heating and cooling loads for the different rooms? And this little visual shows you just how important the windows are, for example, in cooling. They represent almost a third of the total cooling load. And in heating, similarly, the walls are the big thing, along with, what is this, infiltration down here, I guess. You can print this result, use it for your clients or your own personal project, and once again, hit save.
All right, Bruce, so what are some of the things we should remember about HVAC Street?
Well, we hope that you find the program intuitive and easy to use. I can tell you the 5 biggest mistakes I typically make. Maybe that'll help the rest of you. Always pick the right weather location. If you don't pick the right weather location, you will get the wrong answer. Picking that original default insulation level is critical to getting more accurate answers and saving you time. If you want to customize, that's what the overrides and options are. A lot of times you have local knowledge or specific knowledge about the site that can improve the accuracy. And if you are a little confused on any question or what the program is asking you, the question and answer helps. That hover over help sure can be useful too. And before you move on, please hit the save button on each level.
Congratulations, you've now completed the second of the HVAC Street tutorials. If you've gone through the sequence so far, you've experienced the getting started and now entering a building. Want to let you know that if you want to learn more about HVAC sizing and anything high efficiency residential construction, please join us annually at the Home Efficiency Forum. This year will be October 17th and 18th in Portland. Other sources of information are at www.betterbuiltnw.com.